All right, let's do problem 47 on page 101. And let me read the problem. Here it is. It says a box is given a push so that it slides across the floor. How far will it go given that the coefficient of kinetic friction is 0.2 and the push imparts an initial speed of 4.0 meters per second? All right, so I've set it up here already. We've got, here's our box. We push it so that it has an initial speed of 4 meters per second, and it's going to slide to a stop. And if the coefficient of kinetic friction is 0.2, how far did it go? What's our delta x? So, well, here's the thing. We know we can find the acceleration using force. And so I usually like to try to start with what we're trying to find. If I can find the net force, I can find the acceleration. And if I can find the acceleration, I can use kinematics. So let's just start with delta x. I know the initial velocity, the final velocity, and I want to find delta x. And I'm going to be able to find acceleration. So I don't know time. So what I'm going to do is use the kinematic equation that doesn't have time in it. So we're still going to be using these kinematic equations. But look, this is given, this is given. I don't know the acceleration, and this is what I'm trying to find. So I can solve for delta x. This is 0. So negative v naught squared over 2a. So this tells me, okay, now you need to find the acceleration. And we can find the acceleration using force. So let's, when we use force, we want to use the 5-step procedure. So let's do that. Let's draw the free body diagram. Here's my crate. Here's the force of gravity. I'll call it m times g. Here's the normal force that's supporting the weight. And here's the force of friction, right? It's sliding to the right, so therefore the kinetic friction will be to the left. Now here's a place in this problem where students will make a mistake. Students think that there must be a force pushing it to the right, but you've already pushed it to the right. Somebody took this crate and pushed on it and gave it this initial velocity, and then they let it go. So it slid to a stop. So there's no more applied or outside or pulling force or pushing force or anything. The thing that's making it stop is this kinetic friction right here. So don't accidentally add any additional forces. These are the only forces acting on this box as it slides to a stop. I'll define to the right to be positive x, and this is y. Okay. None of these forces need to be resolved into x and y components. They're all good. So now I'm ready for step 4 of the procedure. Okay. So I look in the x direction. There is only one force, and it's the negative force of friction, and that's going to be equal to ma. So the acceleration, which is what I want to find, is equal to the negative force of friction divided by the mass. Now, I don't know the mass. The mass was not given, but it's too early to panic because we know we can get an expression for force of friction. We know that the force of friction is equal to mu times the normal force, right? Force of friction is equal to mu times the normal force. So now I'm going to sum the forces in the y direction, and you'll see y here. The normal force minus m times g equals, and remember there is no acceleration in the vertical direction in these problems, in a problem like this one. So that means that the normal force is equal to mg. So now I'm going to substitute that and put it in there. And so I got negative, and then mu is 0.20. And then this is, and well, let me not do that. You could do it right now if you wanted to. I'm just going to try to do this so it looks nice and neat. Mu, and then what is the normal force? mg. But we already divided by m. And do you see now? See why I didn't need to give you the mass? It cancels out. So the acceleration is just equal to negative mu g mu so the acceleration is negative 1.96 meters per second squared. Now I can take that and plug it in here. So this is 4 times 4 is 16, divided by 2, divided by 1.96. And so our delta x should be equal to 4.08 meters, or 4.1, depending on how you want to round it off. Let's check the answer in the back of the book. This is problem 47, and it is indeed 4.1 meters. Yeah, I should have rounded it off a little bit more, maybe to 2 significant figures, because look, our numbers are given in 2 significant figures, so 4.1 would be a little bit more proper. 4.1 meters. Did it right. So what do I do after I look at the answer and I get it right? I reward myself with a great big old red star. Now, so let's review this. Here's the thing. Here's a strategy. If you have a problem where you're going to need to use kinematics to solve for your unknown, you're going to be able to find the acceleration using force, using F equals ma, right? So go ahead and solve it as best you can using kinematics, and then when you need to say, oh, I need to find the acceleration, then you go ahead and do the procedure, the 5-step procedure to find that acceleration, and then you plug it back in here and you get your answer. I hope that helped. If you have any questions, you can leave it in the comments below. But that is all.